Hi, my name is Tim Baumgartner, and I'm presenting UKP-SQuARE, an online platform for question answering research. So what is SQuARE? SQuARE is an online platform where NLP practitioners can interact with modern question answering models. We call these models skills. On the platform, you can easily get the outputs of multiple skills and compare their predictions. SQuARE also implements the common QA pipelines. This way you can very easily configure a pipeline and create a demo of your own QA model. If your model requires something more special that is not covered by the pipelines we have already implemented, you can also implement your own QA pipeline and share it with everyone on the platform. To deploy your own model, you just need to implement a single Python function and integrate it into SQuARE. Another major component of SQuARE is explainability. For the existing skills on the platform, we perform behavioral tests in order to systematically analyze their strengths and weaknesses. So why did we build SQuARE? First, when we create a demo system for any NLP model, there are several engineering challenges that we as researchers might not be very familiar with. That could be designing a nice user interface, implementing a secure system, or maintaining and keeping the demo up and running. Also, demo systems typically only feature a single model, and you cannot compare outputs of different models. With SQuARE, we aim to provide a system where researchers can very easily create and host demos of their models and do not need to worry about the engineering part. Also, by providing a single hub where many QA models live, it becomes very easy and transparent to compare different models. Another reason for SQuARE is that question answering has become a general framework in NLP. Many tasks can be framed in a question answering setting, and QA tasks exist in many formats like span extraction, multiple choice. Therefore, a question answering platform allows to test many capabilities that NLP systems require today. All common QA formats are already supported by SQuARE, and with the first release, we also provide about 40 models for users to explore. In order to use our available memory efficiently, we mostly use adapter-based models, which in practice are on par with fully fine-tuned ones, but SQuARE is not limited to adapters, and basically any model that uses the Hugging Face Transformers library can be used. Last but not least, implementing QA pipelines is also particularly challenging because modern systems often require combining multiple models. For example, an open domain span extraction model requires a document encoder with a fast and efficient embedding storage, a query encoder model, and a span extraction model. In SQuARE, we host many of these models that can be used by all users. Further, we provide a set of background knowledge data stores like Natural Questions Wikipedia snapshot or web documents from MS Marco. Also, users can dynamically add models that they need to the system. Now that we learned about what SQuARE is and why we implemented it, let's have a look at the live demo. So first we go to the QA side, and here in this dropdown we can see all available models in UKP-SQuARE. And for now we select this model that is fine-tuned on a core reference resolution question answering dataset. Here in the middle we can enter our question, and since this is a span extraction model, on the right side we can provide the context. Now for this demo, we will just select one of the example questions. And now if we scroll down, we can see the extracted answers by the model along with the confidence score. And we can also see the answers in context and get to highlight where the extracted answer is coming from. Now let's see how we can use SQuARE to compare different models. For this, we select two more models, one that is fine-tuned on Squad and another one that is fine-tuned on UseQA. And for now, we can just ask the same question again. And now when we scroll down, we see these in a nice table overview side by side. And we can see that indeed these models produce different outputs for this question. Now let's have a look at an open domain question answering setting. So for this, we select an open domain QA skill. For example, this one is using BM25 on Wikipedia and a squat fine-tuned BERT model. We can again select one of the example questions and now get the outputs of the model. And we can already see that these outputs are likely to be wrong. And if we look at the answers, the document, the background documents, we can see that these documents are not really relevant. So now let's see how we can improve on this by, instead of using BM25, using a dense retrieval model. For this, we go to My Skills. We want to create a new skill, so we click on New. Let's give this some name, like OpenSquat DPR. So we will be using the dense patches retrieval model for retrieving documents from Wikipedia. We will select span extraction skill type since we still want to extract a span. And the QA pipeline is automatically selected here. And since we want to just reconfigure this pipeline, we have to provide some arguments to the pipeline, like how it should be parameterized. For this pipeline, the following parameters can be set, and we provide some documentation on what parameters apply to each pipeline. And we can also go through them here. So as a data store, we will be using natural questions, in other words, Wikipedia. As a reader model, we want to use BERT with a squat-based adapter, and we want the reader model to extract the one answer per document. And now also, since we want to use DPR instead of BM25, we simply select a different index, namely DPR. That's all we need to do for now, so we can just save this. And if we go back to the QA side, now this skill is available. We can now ask the same question again. And we can see that the answers now are much more plausible. And if we look at the retrieved documents, we can see that they indeed seem to be more relevant. Now let's have a look at the other major component, namely the explainability. So we provide behavioral tests, which test basically whether a model has certain capabilities or is robust to certain inputs. So for example, let's go back to our initial example where we compared a squat-based model with a model that is fine-tuned on co-reference resolution question answering. And here we get an overview over all existing test cases. Now if we have a closer look, for example, at this co-reference test case, we can see that the squat-based model performs worse than the co-reference resolution model. And we can also have a closer look at the test case that is still failing. For example, when we provide the input "who is a nurse" with this context where Robin is a nurse, the model incorrectly predicted Martin, though the correct answer would have been Robin. And there are several more test cases like this. For example, exploring negation or exploring if the model is robust to different genders. Those are the major features that I wanted to share with you today. I encourage you to try out the system yourself and stay in touch with us. And if you have any questions, then feel free to check out our poster and come by to have a chat.